Good morning, students. Today we learn the next part from your chapter, that is non-directional bonding. Before that, we have to revise our second lecture, that is we have to start this lecture with the radius ratio rule. It is a very important rule which explain about the stability of whites by means of radius of cation and divided by radius of anion. Then we have to learn limiting radius ratio rule. This rule explains about the stability of ionic compounds. Then we have to discuss about the types of ionic crystal. There are 5 types of ionic crystal, and out of that, from our syllabus, that is one we have to complete structure of NaCl. Then we have to learn very important lattice energy. You have to remember the two definition. One is by the formation and one is by the dissociation. After that, the lattice energy depends upon these three factors: ionic radius, ionic charge and electronic configuration, that you have to complete in detail. And very short part from the syllabus, that is Bond-Landis equation and Kapuscinski equation, is used for the determination of lattice energy. So students, the next continuation part is very important, Born-Haber cycle. In 1919, two German scientists, M. Born and F. Haber, developed a technique for determining the lattice energy of ionic compound by experimentally. So before this Born-Haber cycle that we have to learn, it's only explain about the theoretical calculation of lattice energy. It is the first attempt and good attempt for determination of lattice energy of a ionic compound by experimentally. So student, this method based on the definition of lattice energy for ionic compounds Mx. So you have to just remember the definition, and they explain by two alternative ways. So in case of lattice energy, how this Mx ionic compound is formed depend on two alternative ways. We have to complete one by one. Number one, direct method. So very interestingly, students, the direct combination of M, what is S, it is solid in nature, plus half X2 which is gas in nature. So what we just say that here, students, when a metal in a solid state combined with X2, that is halogen gas, they are combined together to form Mx ionic compound, very important, which is a solid in nature, and we get a delta HF. What is this delta HF? So it is nothing but heat of formation, which is indicated by minus X kilojoule per mole. So what we just say that, students, here the direct method in which M, metal in solid state, directly combined with X2 gas, there is a formation of ionic compound Mx, which is solid state. So it is a one way where we can calculate the lattice energy. Number two way is like this, alternative method, which is called, so what is nothing but we have to consider here a number of steps are used for the formation of Mx, and they are 5 in steps. We have to complete one by one, students. Number one, so you just keep in mind that in direct method, we have to take metal in solid state and directly combine with the gaseous halogen compound, we get an ionic compound. But in case of alternative method, we have to go a one by one stepwise consideration for getting the lattice energy experimentally. So number one, sublimation of MS to M gas. That is very simple. Conversion of metallic solid atom into gaseous atom. So what is the first step, students? We have to sublimize the sodium solid metal into sodium gas. So very simply we have to just remember that sublimation is nothing but solid to convert it into gaseous. So what do you get when the solid metal is converted into gaseous form? We required energy, very important, students. We have to convert the solid metal to gaseous. We required a energy. That energy is called as heat of sublimation energy, which is indicated delta Hs, which is which is equal to plus kilojoule per mole. Plus indicate energy required. Number two step, dissociation of half X2 gas to X gas. What is simply the conversion of gaseous halogen molecule into gaseous halogen atom. Very simple approach like this, students. So what you hear, the all halogens are present in X2 form in the nature. So that half X2 is going to do X gas, both are gas, and now we just say that it is dissociation energy where X2 molecule is converted into X gas atom. So again here the energy is required. So half delta Hd is the dissociation heat of dissociation energy. This is plus kilojoule per mole. Number two step. Number three, the ionization of metal gas to metal plus gas, that is conversion of gaseous solid atom into gaseous metallic ion. So students, here we have to convert gaseous metal into their cations form in gaseous state. So that is nothing but how we can get this process. Very simple, by giving some amount of energy and one electron, valence electron present in an atom, they are just removed from that shell, they carry a positive charge. So this is called as ionization energy. That is again we just say that delta Hi is a ionization energy, which is nothing but plus kilojoule per mole, which indicate again plus sign indicate energy is required. So in this step the sodium atom in gaseous state is converted to sodium plus gaseous state. Number 4, the conversion of X gas to X minus gas. So very simple, the conversion of gaseous halogen atom into gaseous halide ion. So what we just get the meaning, the Cl gaseous atom is now converted to Cl minus ion. So how it is to be estimate, it is called as electron affinity, so which is indicated by minus X kilojoule per mole, where the energy is liberated. Very simple, students. Here the Cl atom in gaseous state converted to Cl minus gaseous state, where the amount of energy required to get one extra electron in the outermost shell, that energy is called electron affinity, which is the energy is released, that is called electron affinity, which is indicated minus X kilojoule per mole. Now the last step, students, the combination of M plus gas and X minus gas to form Mx in solid state, that is conversion of gaseous ions atom to form solid crystal. So we get a sodium metal, sodium cation combined with the Cl minus ion, that is chloride ion, we get NaCl in solid state. Now, and this is nothing but delta H is a lattice, and which is nothing but U, lattice energy, and the amount of energy is released, which is called minus X kilojoule per mole according to definition of lattice energy. So student, we have to sum up this all step one by one for your better understanding, which is also important for the writing part in exam. When Mx, that is solid metal, combined with gaseous halogen atom, there is this method is called direct method. We get M ionic compound Mx in solid state. This is called direct method, and which is nothing but heat of formation, which indicate delta HF. This is called direct consideration. Now the alternative way or alternative method, first we have to convert metal, solid metal into gaseous metal by means of heat of sublimation energy. Now the gaseous halogen molecule are converted into gaseous halogen atom by means of heat of dissociation energy, which is always half. Now metal, gaseous metal is converted into cation metal in gaseous state. The energy is called heat of ionization or ionization energy, and the X gas is converted into X minus gaseous state. That energy is called delta He, which is electron affinity. And when this positive sodium metal positive and X minus negative in gaseous state, they are combined to form Mx ionic compound in solid state. The one energy is liberated, that energy is called lattice energy, and that cycle is called Born-Haber cycle, that we have to learn in detail.